bounded backlog and bootstrapping. Current backlog will soon have the core functionality, but further improvements will be needed now and in the future. E.g., there's a challenge with the bounded backlog when bootstrapped nodes have a discrepancy in their cementing speed. Proposed solutions. Using a vault cache to manage non-live blocks can significantly improve cementing speed, potentially increasing it tenfold. Frontier scan optimization. Implementing a dynamic frontier scan rate could enhance bootstrapping speed. Current observations suggest disabling certain rate limiters to maximize bootstrapping speed, but this has to be tuned carefully.
Early block filtering and spam rejection. Plan post-merge. After the first version of the bounded backlog is merged, Pyre has an idea to implement an early block filtering mechanism to reject spam before it's checked into the ledger. Implementation strategy. The ideal solution involves a multi-threaded read-only block checker, which is currently unavailable. Instead, a callback function could be passed into the ledger processing logic to filter blocks before inserting them into the ledger. Technical challenges. The implementation details are pending, requiring further exploration of the ledger code. The concept may be feasible with a Boolean check after verifying the block sideband. Rust port of Nano has been fully ported to Rust, which allows for further development. Focus on code cleaning, refactoring, and testing. Technical improvements, compatibility with existing tools like Grafana, allowing developers to compare the performance with the C++ implementation easily. Development status. Merging upstream commits is ongoing, and future tasks include stabilizing the implementation and addressing potential bugs. The WebSocket server, previously integrated within the Nano node, has been extracted into an independent crate. Benefits of separate crates. This modularization enhances encapsulation and allows for independent modifications to components like the ledger or WebSocket server. Discussion on consensus termination and potential epoch proposal. Initial discussion. Current consensus does not guarantee termination in the case of disputed final votes, which could lead to manual intervention if consensus stalls on specific accounts. However, due to final votes, decentralized gossip, and the block lattice ledger structure, this is an edge case that hasn't been able to be reproduced and would be limited to misbehaving accounts. Inventing an epoch-based ledger division could address this without requiring consensus changes by automatically dropping unsolved elections from previous epochs and allowing stalled accounts to resubmit transactions in a new epoch. After consideration, research into consensus algorithms and potential tweaks to existing structures is ongoing, with current priorities focused elsewhere due to the low probability of consensus stalls affecting non-malicious actors. Additionally, features like vote storage can help alleviate some of the bootstrapping traffic concerns. Nodes are already partially implemented and can significantly reduce representative bandwidth usage, making them an effective measure alongside or instead of certain proposed optimizations like epochs. The port maintains compatibility with existing tools like Grafana, allowing developers to compare the performance with the C+ implementation easily. Development status is ongoing, and future tasks utilizing the measure alongside or instead of certain proposed